Good evening, everyone. Myself Sowmya. I'm from AML department. Today I'm teaching the topic of linear regression in machine learning language. Machine learning algorithms is basically how the logic will be divided into supervised or unsupervised different ways. So linear regression mostly considered as a supervised machine learning language. So here we mainly predict the different types of results by using existing parameters. We can use to labeled and unlabeled both. So whereas coming to definition, linear regression is a type of supervised algorithm to learns from the labeled data set and predict the existing values from the new things. So where linear regression is very important, the first one is simplicity and interruptibility. So simplicity is like it is very simple to implement. We mostly take a smaller scale data sets also we can implement. So then we can predict easily the next coming up values by using small scale of parameters. Next, predictability. Predictability is like most kind of a decision we can make by using that predict range. So it will very helpful when we dealing with the data sets, especially we are assuming the new things where coming to the basis and other models, it will bias sometimes some parameters, but it was not dependent. It will be interlinked with other algorithms. It is easy to implement with the other algorithms also. And efficiency, whereas coming to prediction, efficiency is a main value here. We will get the more correct answers when we are predicting the new values. So it is widely used. It is like a simple algorithm for the basic kind of prediction values. So it is very easy and widely used for the simple predictions. Analysis, we can analyze the data existing one and predict the future values very easy way. So analysis also it will do good way for a trained data. Whereas linear regression, we mainly depends on the data points. Like by using these data points is nothing but prediction trained data values of each table having different result sets. So by using those existing data sets, we can predict the newest thing. How we will predict? By using this kind of fit line. We call it as a best fit line. Best fit line is like minimizing the prediction range. If I say my prediction is here, original prediction is here, I get the prediction value on this, so I can take a nearby value here. So then it is easy for us to concat the that prediction range, and calculating coefficient variable minimize the error prediction. So simply we can say this point A is the predicted value from our side, and point B is the original value what actually in the market. So we can use coefficient function and calculate the in between range, and we can narrow down the prediction value exactly what we can assume it. So where is the equation is y equal to mx plus b. Here m means we can say slope. So we will further we will discuss about what is the slope and what is the interception in further slides. So this is a basic equation how we draw the best fit line by using these value y. So whereas coming to the prediction, this is called as an intercept point, where the value x equal to 0, the where y is started, that called as a interception value. Next, whereas coming to the slope and where the first point to second point, the angle of this place is called as a slope. So these are the main 2 points we can use it. This line is drawn from the by using y value. So where x is dependent and y is the independent value. So where coming to the main linear equation, y we'll say 2 kind of equations we can say. Y equal to a plus bx, where the y is a prediction dependent value, and y is equal to mx plus b also we can write. X is is the input, that is the independent value where we get the trained data set values. Y is the dependent value where we derive it from the x values and slope and interception values. So we can say B is intercepting point where the x is 0 and the y value starts. So this is a main equation, whereas coming to just different notations, hypothesis functions, sometimes non-linear regressions also possible. So that non-linear regressions are coming from this equation. So depends on that, we can say non-linear or linear regression, we can differentiate it. Next, whereas coming to variable roles, dependent variables are the variables whose value wanted to explain the forecast. So dependent variables is like it will not directly individually derived. It is derived from the independent values where the existing trained data holds it. Next, its values is depends on the something else. So suppose here we can say y is equal to mx plus b. Here y is dependent on this x value. If it varies from the it varies depends on the x value, whereas independent values are like they are the values, it won't change throughout the process. The values are explained by others. So the we here the x we called as a independent value, y is we called as a dependent value. Whereas here the two main objects we will derive it is a slope and intercept point. Slope is the best fit line, indicates how much the dependent variable changes for each x value changes. That means how the value y is changes, each point of x changes. Intercept is like where x equal to 0 means where the y stands for. So where the y line is started. These are the two important points we will derive all over the linear regression algorithm. So there depends on the perception and best fit line. There are two types of algorithms: simple linear regression and multiple linear regression algorithm. So we mainly concentrate on simple linear regression to predict the values. Multiple linear regression also we will use depends on like a dynamic environments like real estate pricing and stock marketing pricing. All these are real-time dynamic changes. So these are the multi linear regression. Next, simple linear regression follows this equation. These equations here last time we say y equal to mx plus b, or y equal to b plus mx. So here b means the b naught, beta naught, where the interception point is changed. b1 means a slope. Each and every x value changes, what is the value is changing. And whereas sigma is called as a error rate. Error rate we will say. So what is error rate? We'll check it in the coming up slides. So these are the some real-time examples. We can say by using linear regression algorithm we can predict the different values. So some first one is a stock market prediction. We'll do day-to-day trading. So where we the sell the particular entity is closed, or the particular entity is buyed or sold throughout the full day trading. So this is predicted by the linear regression algorithm. So we can decide where the actual price we can buy or sell. Next, coming to the real estate price prediction, like different areas having the different prices of the houses. So we'll say what is the coming up price bracket. So now the areas are buzzing somewhere. So how we can estimate the price for the next 10 years, next 20 years of house price prediction. Next one is a medical risk prediction, where it is comes to healthcare industry. We differently used in the report analysis. For example, I'll take a cancer prediction. So by using the medical risk variables, like if I wanted to predict the cancer level, I will see the tumor size and tumor different kinds of medical terms. Depends on those factors, I will predict what is a cancer level. Next, sales forecasting. We'll say like if I take an example as a car selling. we can predict the next bracket price coming up if the new model is coming in the coming years. So how the price bracket will be, what is the price will be expected in the market. So these all are the things, some real world examples we can predict using the linear regression algorithm. So we can say constant variance. Sometimes linear regression won't be always a straight line. So we can say the error should be equal spread across the values of inputs. If the spread changes like fans, shrinks, so sudden changes in the prediction, it sometimes spread all over the data points will be spread all over. So if my data points are accumulated in a single area, like a high density area, I can say homodensity area. If my prediction is somewhat not predictable, or spread, my data points spread all over the area, I can say heterodensity area. So the linear regression is basically non-linear and linear. So depends on the data points. The linear regression is the data points is particularly located in a single area, and I can draw a straight line by connecting all the matched data points. I can say linear regression. If I say if I can't able to start from that here, and I can't particularly draw the best fit line, I can say non-linear prediction. So generally we will work on the only linear regression. We won't work on the non-linear regression by using simple linear regression algorithm, because we can't draw the best fit line by using these data points. Next, I wanted to explain how we will calculate the best fit line and how we will derive it. So here I consider the one example. Suppose to student want to predict the data final exam score based on the hours of study. So already we given this set of data like that, hours of study, 1 hour if he studied, he got the 2 marks in the external exam. Like that I have a data set of 5 entries with respect to of all the marks they got in the final exam. So here I wanted to calculate how I can derive it. So I find out the first number of hours of mean square. So I find out each and every one's hours calculation. Same like I can derive the x into y, each x values, how the y is changed. So I'll find out the means of both. So then I introduce this one into I find out the two main parameters of the linear regression by using previous values of this table. So here the slope formula is the summation of this one. So slope formula is like that. So directly submitting all the values what I got in the previous state. So I got the slope is, my slope is 0.6. So same like a intercept value is the summation of all these things. So what are the parameters? I directly induce the values what I got in the previous slide. So I got a intercept point as a 2.2. So this 2.2 means is that x is changed when x is 0. When x is 0, my best fit line is started from the 2.2. So where the starting point is lies, this is B. Okay, then the data points we will intercept. These data points are derived from the particularly this table, what the value and respected x and y values. So after getting it, I need to implement this equation. So each and every value I'll do it. So here I derived the y value here. So next I wanted to predict the student who is studied 6 hours. What is the final prediction score I got in the exam. So after applying all this, I got the prediction value is he will got, if he studied 6 hours, he will get the 5.8 mark 0.8 marks he got in the final exam. So whereas when we represent it with the best fit line, like I can say this is my best fit line, but even though it is not touching any data point, I got by introducing the y value, I draw a one best fit line. So now where the sigma, we will say, the error rate. So suppose my line is passing through here, but the original data point is lies here. So the difference between here, we call it as a sigma. That is the error rate of the best fit line and the original prediction value. So now the how I can decide the best fit line. Whereas coming to the regression equation, if I say my x is 2, then my y value comes like this. If my x is 2, then my value is this. So I draw the different types of best fit line, each and every prediction. So here I can say the value is 4. Where the interception point. So interception points may be a positive or negative, both sides will be there. So where we can say we can take the in between high range and low range. In between we decide that this is a best fit line we can consider for the prediction. So what is the advantages of linear regression? First point is linear regression is relatively simple algorithm, making easy and directly we can submit the original values trained from the trained data. Then we can predict the upcoming data what we wanted actually. Next, linear regression is computationally efficient, handle the large set of data very effectively, because we are doing very less mathematical operations compared to other algorithms. So it will work and predict the proper range even though it is a large time data set also. Next one is linear regression relatively reverse the outlier compared to the machine learning algorithms. So the similar impact overall the model perform. So for linear regression, the model will change affect all over the things. It's not like a single value we are not predicting, we are predicting range. That's why we can say the overall results will be analyzed in the linear regression. Linear regression serves the good baseline model comparison, more complex machine learning algorithm. So comparatively other than like random forest, all other algorithms, linear regression is the best one and the simplest one to implement, and for the easy predictions and dynamic predictions also sometimes. So linear regression is a well established algorithm which rich history, widely available various machine learning. So it is a basic the first term of machine learning algorithm we can use everywhere for the real time predictions. Whereas coming to disadvantages, con sides of the linear regression. Linear regression assumes the relationship between the dependent and independent variables. The relationship is not linear. If it is a non-linear function, it will create the issue. If it is linear regression having the linear kind of curve, everything works well. If the data plot is non-linear, the problems arises in the linear regression, because we can't draw the best fit line and we can't predict exactly what is good prediction value. The linear regressions as a sensitive multi-collisionary and which occurs where when the high correlation between the independent and dependent, multi-correlation inflate the variance. So here the second point defines that the linear regression, if it is a single thing is okay, but if it is multi-correlation values like a dependent and independent more values, it will create the more error rate. So that will violate the original prediction value. So we can't predict a single proper prediction range. So linear then next point is linear regression assume that futures are already suitable model. Future engaging may require the transform futures format, and a model can be effectively used. Sometimes we can't get the independent variables directly. The trained data is not enough to derive the what is we require the prediction values. So that is sometimes having the issue. Next, linear regression provide the limited exponentially and complex relations. Linear regression morely work like two or more parameters. It's a very good result and analyzed, but when we comes to a bunch of parameters we need to analyze, it will be clumsy in the linear regression. These are the common applications as we already discussed previous slide also. Next, this one is a gradient descent work in the linear regression. It's a gradient descent means like this is the this is a thing where the original value actually in the market and what is the predicted value we are decided to take. So prediction is like a to B range. So we can take either A1 or A2 or AZ or B0. Like that we can take any value in between. So to minimize this kind of range, we use the gradient descent value to minimize, and between we will choose any other single value how the exactly the prediction lays. Simply we are narrow downing the value of the prediction range by using gradient descent graph. So here the best fit line data points we already draw in the last time, like x and y axis, and we draw the data points here and here and here, and we draw the best fit line. Here the range, like here we got the data points in the some best fit line on top of best fit line. So here we can take a range of this one. So here these points we denote in the curve based. So then we can define the where the curve is exactly properly. We can choose the proper in between value, so that we can select this point is a proper value for the prediction price. So let's calculate the slope of the point. From this point to this point we can calculate the slope, and by using this formula. So each and every point we calculate the slope, and finally we will decide the where we need to choose the exact single point of the prediction value. So here it is how the gradient descent algorithm is worked. First we will calculate the slope, and then we will calculate the a naught to until like these are the data points. See here the best fit line. From this best fit line, every data is located in the different location, and we will calculate each and every data point slope values, and then we will check the what is the gap between the original fit to slope value. So next until we will find out the exact matching. So next update the cost function. So here we are calculating cost function and each and every time by using the formulas, this one. Then end of the day we unless and until find the nearest this line nearest point we identified, that will be the prediction price prediction value of that particular thing what we wanted to test the data. So after finding out the gradient descent point, we will predict the exact actual value. So we can see the further calculations and cost function, how to we will calculate the cost function, and how we use the different parameters, MSE, MAE and RMSE and coefficient values. We'll see in the next lecture. Thank you.